Okay, so let's go ahead and go through this step by step. I'll show you exactly what I want you to do. All right. So, question number one, we need to get rid of plus 7. So I subtract 7 from both sides. So now these cancel. X equals -3 minus 7, -10. All right. Number two, how do you undo a fraction? We always say you multiply by the reciprocal. So what's the reciprocal? 7 over 5 times 7 over 5. Cross out, x equals. Now you're asking yourself, 5 goes into 5 once, 5 goes into 25 5 times. -5 times 7, -35. All right? Let's go on to number 3 now. Number 3, we have a proportion. So we cross multiply. So the first thing we're doing is multiplying these two things together. So that's 2 parentheses 3x plus 6. And now I'm cross multiplying this way. All right. And that would be equal to 3 times x minus 3. After you cross multiply, now we're going to do is distribute. Distribute the 2, distribute the 2, distribute the 3, distribute the 3. So 2 times 3x, 6x. 2 times positive 6, positive 12. All right. Now when I distribute the 3, 3 times x, 3x. 3 times -3 is -9. Okay, now what we're going to do is we're going to collect the variables. I want to try to move the variables to the left and the number to the right. All right, so in order to do that properly, we have to subtract 3x, subtract 3x. Then we're going to subtract 12, subtract 12. Now again, the reason why we do that is because now the variables are all together and the numbers are all together. These guys cancel out, and now you just ask yourself, 6x minus 3x, 3x. -9 minus 12 is -21. Divide both sides by 3, divide both sides by 3, x equals -7. All right, there's your answer for number 3. Please go back. This is one of the hard ones. Go back, listen to the video again, listen to the recording, double check your work, make sure you're distributing properly. One of the big mistakes is that kids are not distributing properly. So make those notes. All right. Number 4. Now, let's just go ahead and distribute here also. 7 times 3x, 21x. 7 times -5, -35 equals 49. Now we're going to move the -35, so I'm going to add 35 to both sides. So 21x equals 84. And now we're going to divide both sides by 21. Divide both sides by 21. X equals 4. Okay, that's one technique. All right. Now, because some of you guys are doing very well, all right, I'm going to show you the second technique, which is what I really want you to do. All right. But some of you guys made some mistakes. So I want to review with you this technique. This 7 and this 49. All right, it's a lot quicker if you were to just go ahead and divide both sides by 7. All right, now watch. 3x minus 5 equals 7. All right, now from there, add 5. 3x equals 12. Divide by 3. X equals 4. All right, notice, same exact answer. The numbers are just a little bit smaller on the right side. That's all. All right. Now, here we go. Number 5. All right. For this problem, I'm going to subtract. Now, again, this is fraction, so I want to be careful. Subtract 2/9. Subtract 2/9. Add 4. Add 4. All right. Let's see how you did with your fractions. 5/9 minus 2/9 is 3/9 x equals -3 plus 4 is 1. Now what everybody should be saying is, well, 3/9 can reduce. You should always reduce fractions. So 1/3 x equals 1. Multiply both sides by the reciprocal. All right. So now x equals 3. All right. Anybody have any questions? All right. Again, if you're having questions, stop the video, go back, listen to my explanation again until it makes sense. All right. We've been doing these equations for a long time now. Please make sure you're doing a good job with these. All right. Now, number 6. Okay. Again, we're going to distribute 2 times 3x, 6x. 2 times -7, -14, minus 4 equals 5x minus 18. All right, now we have to group things together. So what we're going to do is we're going to group the -14 minus 4. -14 minus 4 is -18. So I have 6x minus 18 equals 5x minus 18. Now, this is a really important problem because, again, we're combining terms, all right? We're moving the variable to the left. We're moving the number to the right. Now, when you do that, all right, you got to be real careful. These, again, cancel. This cancels. Now, this is where I want to make sure you're hearing me. 6x minus 5x is 1x equals. Now over here again, -18 plus 18 is 0. You're allowed to have 0 as a solution. You just can't have 0x. All right? So in this case, x equals 0. That's the solution. All right, x equals 0. Please make sure you listen to that question again. All right, because a lot of times my kids thought that was no solution or infinitely many solutions or all real numbers for some strange reason. All right, x is allowed to be any number and 0 is a number. So please listen to that. All right. Now, number 7, we have another fraction. All right. So what I want to do is I want to do plus 5 minus 3/4 x minus 3/4 x. 8 plus 5 is 13 equals. Now on the side we're going to do 2/5 minus 3/4. 2/5 minus 3/4. Common denominator, hopefully you see, is 20. Multiply by 4. 8 over 20, multiply by 5. -15 over 20. So 8 minus 15, -7 over 20. So -7 over 20x equals 13. All right. Now what we're going to do is we're going to multiply by the reciprocal. 20/7. Now, again, still negative. Negative 20/7. All right, now what happens? These guys cancel. So x is equal to, nothing reduces here. We can make that like 13/1. Negative 260/7. All right, so my answer here, negative 260/7. All right. Let's check out number 8. Again, for number 8, you're going to combine terms. All right. 10x minus 18 minus 7 equals 6x minus 12. All right. Combining terms now. 10x minus 25 equals 6x minus 12. Subtract 6x, subtract 6x, add 25, add 25. Now you see the variables have been combined and the numbers have been combined. Variables go to the left, numbers go to the right. This cancels here, this cancels here. 10x minus 6x is 4x equals 13. And then divide both sides by 4. And so x equals 13/4. Okay, now what I'm going to do is I'm going to see how many people are actually watching the videos. All right. So in order for me to figure out who's watching the videos, I skipped a couple problems. All right. So now if you're watching the video, you will know that I want to add a couple questions. All right. So I want everybody to write down 8A. All right. We're just going to create a new problem. And I want to put 2x plus 3 equals 2 parentheses x minus 1. All right. So I wanted to create just so I know who's watching the videos. And when I check your work, if you have these two problems, then I know you're watching the videos. All right. So what we're going to do here is we're going to distribute the 2. And so I have 2x plus 3 equals 2x minus 2. Now we're going to move the variables to the left. Minus 2x, minus 2x, minus 3, minus 3. Now here, what happens? These cancel, and also over here, 2x minus 2x. So it's 0 on the left side and negative 5 on the right side. Well, 0 does not equal negative 5. Because 0 does not equal negative 5, there is no solution. 8A is no solution. All right? So here we go. All right, we're going to look at 8B now. All right, 8B, I want you to write this. X plus 3 equals x plus 3. So I've told you this many times. When does x plus 3 equal x plus 3? It always equals, okay? So this, if you forgot, you would do minus 3, minus 3, subtract x, subtract x. So in this case, you would end up with 0 equals 0. So you would say this is an identity. And because it's an identity, we say it's all real numbers. All real numbers. All right? So again, those are the two that I want you to write down to make sure that you are listening to the video, okay? Now let's take a look at question 9 and 10, all right? What is the domain, all right? Remember, the domain are the x values, all right? So what I want to do is I want to go to each point, right? And I'm going to darken in for us here the x-axis, all right? So right here is the x-axis, all right? This right here is the y-axis, all right? So what we want to do is we want to make sure that we're looking at the x coordinates. The domain is the x coordinates. So what I did was we draw from here to here. This is there. This goes to this x-axis. This goes to this x-axis. All right, you're trying to figure out what points are on the x-axis, or those points correspond to what x. All right, so what I want to do is I always start from left to right. So this x coordinate is -4. This x coordinate is -2. These two x coordinates, -1. This x coordinate is 0. That x coordinate for those 2 points is 1. And that x coordinate is 1, 2, 3, 4. All right. So that would be considered the domain. Okay. You don't have to repeat letters or numbers. -4, -2, -1, 0, 1, and 4. So I believe correct answer would be C. All right. Correct answer should be C. All right. -4, -2, -1, 0, 1, 4. Those are the x values for all of the points. All right. If they said range, you would then go to the y values. All right. Now, it says here, which is a true statement about the relation? All right. The relation is not a function. Okay. So now we have to remember, how do you determine if a relation is a function? A relation is a function if the x coordinates are used only once. Now, the other thing I want to remind you of is there was this thing called that we worked on, the vertical line test. All right, which basically means if you pass this vertical line throughout the graph, there's only one point that passes through that vertical line. So as I'm going through here, notice what happens at this point right here. At that vertical line, you should be able to see that this point and this point touch that vertical line in 2 locations. If it touches at more than one location, it is not a function. It is not a function. All right. So that was easy. The first answer is correct. The relation is not a function. All right. If I were to continue, all right, there's another point right here where the vertical line touches both points. So it's still not be a function. It only has to happen once in order for it not to be a function. All right. Determine which relation is a function. So again, the quickest way to do that is by drawing a vertical line. So I'm going to draw a vertical line, and we're going to talk about it. Here, b is not a function, all right, because it touches at this point right here, this point right here, this point right there, so that's not a function. All right, let's create another vertical line. So I'm going across here. Uh-oh, right there, not a function. Great. Okay, so now let's look at here. Let's look at D. See these two x values? One is used twice. All right, so one is -2 and one is 3. Every x value can only be used once, so D is not the answer. So that means we know C is correct, but let's just verify. -3 goes to 3, 2 goes to 1, -4 goes to 2, 1 goes to -1, and 5 goes to 2. Notice every x goes to 1y. All right, every x goes to 1y. That's why that's the function. All right, write the data as set of ordered pairs. All right, remember the first one is the x, the second one is the y. So we just say 5, 4.20, 6, 5.05, 7, 5.90, 8, 6.75. All right, very simple. First coordinate is x, second coordinate is y. All right, for 13 now, remember you got to plug -6 in for x. All right, so we say f of -6 is -2 times -6 plus 4. All right, -2 times -6 is 12 plus 4, 16. So we say f of -6 is equal to 16. And I want you to remember that just means -6, 16 is on the graph, okay? F of 4, plug 4 in. -2 times 4 plus 4, -8 plus 4, -4. All right, so again, that just means 4, -4 is on the graph. All right. Here we go. Express the relation as a set of ordered pairs. All right, so 0 maps to 20, 2 maps to 16, 8 goes to 11, and 12 goes to 2. All right, that was easy enough. All right, just plotting the points. Above the domain, I want you to write x, range, y. All right. Okay, number 16, again, what is the domain? So again, to find the domain, you're just looking at the x coordinate that corresponds to each of those points. All right. So in this case, the domain is -4, 0, and 1. All right, only the x values. All right, and because this is the x-axis, those are the numbers that correspond to those points. All right. 17, express the relation as a table. So all we're doing is we're just plugging in -12, -7, -11, 6, -8, -3, 11, -12. Literally, that's all you're doing is plugging it into a table. All right, it's just a different way of writing the ordered pairs. Okay, now the range, okay? So the range, remember, is referring to the y values. All right, so now instead of going to the x-axis, we need to travel over to the y-axis. So that goes that way, this point comes over here, this point comes over here. So I'm going to the y-axis. Again, remember I like to write small to large. So the smallest y value is -5, then -4, then -2, and then 4. Okay? Now, let's take a look at 19. Is this relation a function? So only thing you have to do is look at the x-coordinates. Are the x-coordinates different or are they repeated? Well, you should be able to look at that and say that the two 12s are written twice. Because the two 12s are written twice, it is not a function. Not a function. All right? Now, number 20, is this relation a function? Easy to tell. 7 goes to 13, and 7 goes to 6. 7 would have two numbers, 713 and 76. Therefore, the relation is not a function because the x-coordinate, all right, the x-coordinate is used twice. 7 is used twice. Remember, it only has to be one x value that's used twice. All right, so 20 is not a function. All right, is this a function? All right, so remember, anytime you're looking at a graph, all you're doing is creating a vertical line, scanning the vertical line across. At any one of those points, it's crosses the graph twice. So again, not a function. Not a function. All right. So what I want to do now is, let's look at the next one. Create another vertical line. All right, now I'm just going to move the vertical line across. I don't see any place where those two lines cross in two places. All right, so this is function. All right, that is a function. All right, because it doesn't cross at two spots. All right. Okay, finding f of 2. To find f of 2, we just plug 2 in. So 12 times 2 minus 11. 24 minus 11. So f of 2 is equal to 13. All right. So anytime you're using functional notation, you're just plugging 2 into the x value. All right. Now 24 is a little bit more annoying because you got to plug 8 in. So f of 8 is equal to negative 11 times 8 minus 2 times 8 squared. F of 8 equals negative 88 minus 2 times 64, doing order of operations. Remember, you have to square before you multiply. F of 8 equals negative 88 minus 128. So f of 8 is equal to negative 216. Again, you don't need a calculator for that. Practice your mental math. All right. Number 25. F of 6 equals 11 times the absolute value of 6 plus 2. F of 6 is equal to 11 times 6 plus 2, because the absolute value of 6 is 6. F of 6 equals 66 plus 2. So f of 6 is equal to 68. Simple as that, guys. Plug numbers in. All right, now we're trying to figure out what the output is for each input. So here's 3. So remember, we go up until we get to that point on the graph. Then we slide over to figure out what y value it is. So that was a 5. Now we go over to 7. And then we slide over to figure out what y value corresponds to that x value. And that was 3. All right, then I'm going to go to 9 just to double check them. I go up and over, and again, that y value is 2. So they were correct. Now let's look at the next one. So if x is 2, so again, we go up, slide over, that's a 3. 4, we go all the way up, then we slide over, and that's 9. And then 6, go up. Now I want to be careful here as I go over. It's the same y coordinate. It's 3. Okay, that's not bad. All right. Now completing the table, again, same exact principle. We just plug 3 in. All right. So we say f of 3 is equal to 2 times 3 minus 6. 6 minus 6, 0. All right. Now if we want to know what f of 4 is, we plug 4 in for x, which is 2. F of 5, 2 times 5 minus 6, 10 minus 6, 4. All right, and finally f of 6, 2 times 6 minus 6, 12 minus 6 is 6. Okay, so again, just plugging numbers in. All right, let's go over to this one. All right, so we say f of negative 2, 5 times absolute value of negative 2 minus 4, 5 times 2 minus 4, 10 minus 4 equals 6. All right, so there we have f of 6. I'm sorry, f of negative 2 is equal to 6. All right, don't forget absolute value. Anytime you take the absolute value, it just makes it positive. Okay. All right, now I have f of negative 1, 5, absolute value negative 1, minus 4, 5 times 1 minus 4, 5 minus 4 equals 1. All right, so final answer, all right, for that particular problem is 1. Now, f of 0, 5, absolute value of 0, minus 4, 5 times 0 minus 4, 0 minus 4, negative 4. All right, now we're going to do f of 1, absolute value of 1, 5 times 1 minus 4, 5 minus 4 equals 1. All right, so that's it. That's all there is to the review. Please, please, please review. All right, review your work. All right, go back, check your answers. All right, and again, please be ready for your test. If you have any questions, you can let me know. All right, you guys have a wonderful day.